Gentlemen, welcome. This is a really old Texas Star Sweet 16. It showed up with a new faceplate. And I take it that he wants me to replace this one that's a little buffed out. So this thing's been burned up a couple times. We can tell it's got a little highly modified combiner on it. This is kind of cool. These are old, like 50s and 60s Apollo style breakers. Like legit. Kind of cool. I'm going to take the fan kit off the bottom of it. It's got a newer style fan kit that comes with it, plus all the cables for it. But we're going to ignore all of that. Man, this thing has seen some miles, man. Whew. A input trimmer here. It's corroded. All the electrolytics. He wants to go to Class C. So let me read the note. Pretty straightforward. Upgrade power wires. 4 gauge, please. Class C, silicone wire upgrade. New main relay. We can do that. Coax mounted connectors. So he wants new PL259s, I'm assuming. I have a 2-pill driver, 2290, check power supply. All right. Real simple marching orders. I talked to one customer today. He was at another friend of mine, another customer's house. And that customer said, "Hey, your guy's here." I said, "Oh yeah?" He's like, "Yeah, he's got an amplifier out there with you." And I said, "He does? Bad A. What's the number?" And he just happens to call me today. And I was like, "Well, you'll be hearing from me by tomorrow." He's like, "Well, no rush." I'm like, "No, you'll be hearing from me by tomorrow." He goes, "Well, I sent you up a power supply and a Sweet 16. I'm like, "Well, what do you want me to do it?" And he goes, "Everything." So he wants me to throw the kitchen sink at this. No, it's got old school green dots. No, it can't. Well, half of them got old school green dots in them. And then the other ass end of this thing, so like, this has got stock resistors in it. And as I'm looking at this with you, these have been replaced. Jesus. And these have been replaced down here with way bigger than they should be. So it's a delicate balance with the 10 ohm. We can use the 2-watt big resistors in the 10 ohm spot. But when the transistor burns up, you have no 10 ohm smoke to indicate that you have burnt up shit. This is solid core wire, you guys. Yuck. Man, it looks the same, but it's not. I mean, it looks like it's the same friggin' wire, but it's not. We're going to get into this in a minute. Both of these things he picked up for a song and a dance. Man, that is corroded. Here. The wire's got a green hue to it. Here. You can see non-green hue versus nice, soft, clean wire. Doesn't matter, we're going to replace it. This looks like Romex but it's not. Doesn't matter, we're going to take all this out. To Class C these amps is really easy. On each one of these, you take the choke. We'll use this as an example. You take this choke, we unsolder it here, and we move it over to ground and we solder it down. This one here, move it over to ground and solder it down. Then we can ditch these electrolytics and get rid of a bunch of stuff. But what do you think of this input splitter being hidden down here by our positive bus? Boy, that looks safe. Laid over on its side. I want to rip all this shit out, and I'm going to do it differently. So, there. Done. I'm just going to do all this differently. Now to this. This was made by 491 built. It's on 220 plugs, so 1, 2, 3, 4, 5, 6. This is a 600 amp power supply. It's held together by wing nuts, aluminum bars, and zip tied down double phenolic board, which isn't all that bad. 2 breakers on it. And the switches have been broke off this curling breaker here. This one's broken. This one still has a switch. So he wants me to check this power supply. Some of these joints are kind of cold. It looks like it just didn't have quite a hot enough soldering iron when it was assembled. So I think we'll start with the power supply first. I think all of these capacitors, I don't know why these have been lifted. All these do is suppress any AC noise and help throw the positive and negative bus out of RF resonance, if there is any RF resonance. We've got a broken fan wire going up here to the fan. A broken, way too small of a resistor on the ground. Way too small. Okay, well, let's start the unfucking. Gentlemen, my name is BBI. I fix shit. I talk about it as I'm fixing it, then I put it on the internet. I'm simple. Enjoy. Let's go.
Undercover on the beach, you're twerking.
Okay, all you guys watched part 1 of this series, and that was the same intro that part 1 that was in part 2. So we're going to move over to the Texas Star. What we've done is we've lifted all the positive leads off these electrolytics. And what had going on when I first plugged it in is this thing would go zzz, bap, pull an arc. Usually when these caps charge, that's it. I could take the lead and I'd sit there and retouch it and it's going pop, 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 pop. Now I don't have that issue, but one of the things I can't help but notice is we've got one transistor in here that's just making its own heat. So usually when we see that, we know that we've got a leakage going on inside the transistor itself. It's leaking positive shmoo to the negative shmoo somehow. We shouldn't have any shmoo leakage at all. We should have 12 volt over here, and then we're going to have a little bit of leak current, if we have any, over here, which we do, 0.1 of a volt. Now because these are all tied together, we're going to see a little bit less the farther we get away from this transformer. So let's sneak in here and 0.63, 0.5, 0.5, 0.4, 0.38, back of the transformer, 0.38. But we're seeing a negative voltage. Transistor still about 83 degrees or so. transistor shouldn't be getting hot on its own. There's no bias applied to it. So I'll hook it up and run it, but I have a feeling that this one transistor, just simply because it's making heat without having any input signal put into it, that we have got a problem, Houston. Actually, matter of fact, I'm pretty positive we've got a problem. But let's take and run it real quick and see what we got for input schwers. Now we can't make it do full power because of this clip. It's a 50 amp Anderson clip on a device that can pull up to 200 amps. Doesn't seem safe to me. I don't know about you, but I mean, everybody's idea of safe is relative. Okay, so we got 1,000 in peak, 1,000 in average, 5 watt slug in reverse. Okay, amp is off, hello, 1, 2. We're getting up about 20 watts into it, average, and about 50 watts peak. Hello, 1, 2, 1, 2. So now, you can see we got transistors lighting up all the way across the board. Good there, good there, good there. This combiner is getting hot. Output combiner is getting hot. This stage is cool. Our input SWR isn't too whack. So this is a 5 watt slug in reverse from the 955, and then we can look down here on the SWR bridge on the front of the radio. Hello, audio. Relatively high SWR, but this has got a manual tune on the input side of things. It's the heating in the one transistor that's got me very concerned. So that one's at 88 degrees. This one's at 84, 82, 82, 80, 80, 82.2. So this one's running a little bit hotter than the rest. So these transistors are way down on heat now over here. So this one partnered with is 81. This one's 84 degrees. So we can obviously see it's a little bit hotter than the rest. This here is our combiner. Okay, output combiner, that's imbalanced. But then we got this combiner here, which is ice cold. Ice cold. So it tells me this front half of the section of the amp is fine. The imbalance is in this back half someplace. One transistor that's independently staying hotter than the rest. '83. Paired partner, 80. Back transistor, 80. This other paired transistor, 80. .84 degrees. Hello, audio. So, have a little bit of fun here. There's a variable capacitor that's here. Hello, audio, 1, 2. Okay. So we just adjusted that capacitor down. Now let's look at our input tune. Hello, 1, 2. So that made that happy. Hello, 1, 2. Let's see what it looks like on the spectrum analyzer. It ain't gonna be God's gift, I can tell you that right now. Let that boot. '87, 84, 84, And that whole area back there is just getting hotter than hell. 87, 82, 82, 82, 82, 85.3. Well, shut the amp off. Ooh, look at the pass-through tune. Whoa. Oh, now it's back down. It was way up through the ceiling. It tells me that relay is going bad. Okay, baseline, hello, 1, 2. Hello, 1, 2, 1, 2. Yeah, we got some kind of weird harmonic going on. If I was a betting man, I'd say that this one transistor is getting ready to fail. It's internally got a problem. It's got a little bit of leakage. It's leaking positive voltage from here to here. Now, I have had happen in the past where the harmonic suppressor, this capacitor, breaks down and it lets a little bit of voltage through. That could be our problem. So, how we test for this is we're going to let the amp cool all the way down to 0. So everything's going to mellow out, chill out, get down below 80 degrees. I'm going to come in, I'm going to unsolder just this cap, we're going to plug it back in and see if the transistor heats up. If it does, then we know the transistor is bad. It has to be replaced. No ifs, ands, or buts about it, it has to be replaced. I can't in clear conscience let that go out of here like that. And we know we have an imbalance somewhere on this end of the amplifier. Just because of that heat and that heat. And we're not going to mention the fact that the balancing resistor here is plumb broken half. Like, broken half. Ignore that for right now. So let's let it cool down and we'll repeat some tests here. Okay. So it's been 20 minutes or so. A little fan blowing on it here. So we're down to 74, 73, 74, 73, 74. Universally all the same temperature, no hot spots. So let's see if we can balance this up here for you guys. Let's plug it in. We're looking right down here. $79.3, 79.7. This is the hottest thing it can see on the screen. This is the temperature at the crosshairs, roughly. Okay. Let's go ahead and we'll disconnect this. As soon as we remove power, the temperature's starting to go away now. Okay, so now let's reach in here, soldering iron. We'll disconnect this, resistor in this capacitor. Okay, so now we can see the capacitor at 104 degrees and falling. Now we have a completely unobstructed view of the transistor, which is this circle right here. It's that circle right there. Let's see if I can plug this in one-handed. I think I can. Thomas the Tank Engine. I think I can. I think I can. I think I can. Like I said, every once in a while, it's that capacitor just goes bad. The reason I'm making such a big deal out of this is because it could turn into a huge problem downline. I got another way to test this. Grab a can of compressed air. Let's chill everything down. So off axis is 62. Board right next to it 66. Transistors all the way back up to 87. Its paired partner is 72. This transistor is now 90 degrees. So the colder it gets, the more unstable the transistor becomes. That's scary. No heating down here. No heating anywhere else in the amplifier. Okay, so disconnect all the stuff off the amp. So now what we're going to do is we're going to do a current leak check. And it is pulling 4/10 of an amp, 3/10 of an amp. Of course, I question how accurate this measurement is at this low of current level with this particular fluke and its sensitivity rate. Zero. Woo, look at that. Almost a full amp worth of draw, and the transistor's cold. Zero current draw. 6/10 of an amp. This is already up to 90 degrees. So $40, $50, $60, $70, $80. Here, let's look at one of these up front. Sitting at 75 degrees. Super chill the transistor. That's this black dot right there. Little to no temperature rise. $99 degrees, 100 degrees. It's paired partner. 73 degrees, 100 degrees. Transistor, there's something wrong with it. And it makes sense if we make the transistor cooler, the insulation and all the materials that make up the transistor, that it shrinks, right? Spiked up to 1.5 amps. We're at 1.1 amp now. 9/10 of an amp, 8/10 of an amp, 7/10 of an amp. Do it again. 1.5, 1.4, 1.5, 1.6, 1.7, 1.8. And then as the thing heats up, of course, the handy dandy FLIR for the dramatic moment. As the thing heats up, current draw goes down. And then we'll notice the temperature will plateau out, and then it'll drop back down and it'll be back in the 80s again. It's just when I go to start working with this, people say that I've got the gains and stuff all jacked up. There's no way for me to change the gains. When I go to device settings, auto off, display intensity, demo mode, camera information, it just tells me the model number. I got auto power off, Wi-Fi settings and reset. Measurement parameters. I could change the displays on this, and then the reflective temperature, the distance. But there's no way for me to make it read one part read hotter than everything else in the whole amp. It's just impossible. So now we're starting to fall down in temperature range. And our current level's dropping off too. Because now everything around it's getting warm too. Once again, it's paired partner. One's sitting right next to it in this push-pull configuration. This is 70. And that one's at 82. So I feel like I've definitively proven why I want to change one transistor. It's leaking, it's bad, it's got a problem. Okay, so I took these out. This transistor come out of here. This is the one that's in question. So let's take a minute. And I'm telling you, this transistor is going to read okay. That's why it's so hard to sell that there's something wrong with it. I'm telling you, this transistor is borked. Oh. According to this, red and green are shorted. Well, according to the Atlas, that thing is dead. So we'll get the cricket checker out of here in just a minute. It pulses the energy through the transistor differently. No component detected. They both circle in the drain of life? I don't think so. Now it's saying Zener diode red, blue, short. Okay, let's get the cricket tester out. Oh, it can't be that bad. This old thing. Base. Emitter. collector. NPN, lamp on. Base, emitter, collector. Oh. Wow. Interesting. Base, emitter, collector. What? Went ahead and I pulled this transistor out because it's of the same lot as these guys here. These are 4F. And then I pulled one of the stock transistors out, which is a 7D green dot. So I pulled this one out and I pulled this one out. And the idea is to establish a baseline. I've done several over the years that when they show up, the amp still works, but the transistor gains are like almost non-existent. Which, yes, the amplifier is still working. But we want to establish an overall gain field at this point. With those two transistors being down the way they were, see, this has got a gain of 8.5. And this is off this back corner, right? With the gain being down like that, I want to understand. Remember, this is the section with the imbalance in it, and I really think it was, which usually means that this capacitor, that capacitor has gone bad. See, this has got a gain of 5.1. So now we have a problem. Damn it. That means this pair of partners at 5. And I can almost bet those are at 5. And we know that when the transistors get below like 9 is usually my roll line in the sand, that I want to replace all the transistors because, man, it's not going to take a lot of punishment for this transistor to fail. It's just not. And the same thing with this one here. I bet that this one here was at a gain of 2 or 3. And just the heat of me pulling the thing out of the amp was enough to kill it. And this one here was real close to falling through the 4 itself. This is so hard to explain to guys. The transistor's good, but the gain on it's really low, and I can't guarantee that the thing is going to be working for you after you spend all the money to modify the amplifier. This sucks, because there's no trade-in value with the gains being this low. Even though the transistor's good, it's relatively worthless to me because I can't go and I can't build anything else with it, right? I can't use it as a repair part. 5.1. Let's double check this on the Cricut. Oh, is my wire finally starting to break? Thing is only 50 plus years old. Oh, Jesus. Okay. Son of a bitch. Here. Let me grab a brand new Toshiba out of the pile of shit here. Hold on. This is a brand new Toshiba. Legit brand new Toshiba. So this is our minimum threshold of 0, and then you'll notice the LED gets super, or not LED, the neon bulb gets super bright. That's because we've overcome the base turn on for the transistor. And we got both elements lit. Turning off, turning off, turning off. So our maximum gain on this, according to this tester, is a 32. Which is good for that thing. It's got an HFE gain of 80, which is what we've all come to know and love and explore and enjoy life with. Let's grab the one that came out of this hole. I have to get some new silicone wire and put new wire on this. This is, I never ever use this tester, by the way. Okay, so we've got a gain of 22. And then this poor guy, see how it fluctuates from 0 and then it gets bright and then it starts to immediately fall off. This is literally at the end of its life. I mean, like, we fart on that, it dies. This transistor is miles better than that one. Still, they're way down compared to this. So, transistors will do the same amount of watts from 100 HFE all the way down to 0, but it's that last little bit where you can't guarantee the customer it's going to last, right? So now I got to call the customer and I got to explain to him, hey dude, you got parts in this amp, but they're all relatively not worth a damn. An amp technically makes power. This is true. This is totally true. Hell and Jesus will have to come back before I reinstall these back in this amp. I wouldn't be afraid to use this one, but if this one looks anything like this one, and this one, if this is indicative of these front four, let me call the customer. So just got off the phone with the customer. He says he doesn't want to bother risking it, and I explained to him the risks. I said, dude, I cannot guarantee this box to work more than maybe 2 or 3 keys after you get it back with these low gains. I mean, I could go in here and I can make this thing look like the Mona Lisa on the inside, and it still could have something go and die. The gains of 5, 4, and 3, I'm assuming that's the average of the fronts. We're going to pull all these transistors out and we're going to check them all. But he says he doesn't want to risk it. He wants to go ahead and just put HGs in it and be done with it. And I said, okay, that sounds freaking fantastic to me. I'm going to tell you a quick story. When I was young and I was afraid to say no to people, and one of the main reasons I started this YouTube channel was because of a local guy and another guy that's just down the road a couple hundred miles. Local guy bought an amp that looked like this off of eBay, drug it over to me, and said, dude, go through it and make it work. So I popped all the transistors out, and at the time I had an Atlas DC55. The highest gain out of any of the 8 transistors, which were Toshibas that were in it, was a 3.2. Now this is etched in my brain from the word go. So I called this guy up and I said, hey man, his name was Rob. He's dead now, doesn't matter. Now Rob was a mimey, trying to always get something over on somebody, drug dealing piece of garbage. He was a human bag of waste. But still, it was amp work. And I was afraid to say no to anybody. Looking back, I should have told him no to go suck a bag of dicks. He said, just get the thing running. I'll sell it to somebody the way it sits. Okay, so I go through the whole amp. I get everything fixed. It had the same kind of burned up deal going on over here where it had a fried trace in the corner and a bunch of stuff, right? So I get it running. I take it over to Rob. I drop it off. I said, here, your amp's done. And I charged him like 75 bucks because I felt bad. And I told him, I said, Rob, do not key this amplifier. All the transistors in here are good, but the gains are like 1 and 2 and 3 and 3. 3.2 or 3.4 was the highest gain out of the whole box. I said, dude, Rob, this thing will not last. The first time it gets hot, maybe within 2 or 3 keys or the first highest WR, the thing is going to fail. He proceeded to take that amplifier and go to our local CB shop and walk in there and straight face tell them, no man, I just got this thing back from BBI. He says it's good to go. Well, they hook it up in the CB shop owner's truck and it made it 2 keys and it let all the smoke out. So my phone starts ringing. Hey man, what the F? Rob said he just brought you this amp and you totally went through it. It only made 2 keys. What do you got to say about that? And I said, well, I told Rob that the gains in that amplifier, the highest one was 3.4 or 3.3. That we needed to replace the transistors. Rob said that he was going to go sell it to somebody and not worry about it, just get the amp running. You'll never guess who ended up having to buy and replace and eat the entire cost of that amplifier. New transistors, Toshibas. Me. So one of the main reasons I started this YouTube channel was because I would do the work on the bench. I would find a mystery problem box like this. I would make it very clear to the customer on the phone, send it back to them. They would have some kind of problem with it. And then the internet was full of people going, what the fuck, you should have done this, you should have done that. Why do you do this? Why do you put that? Why do you reuse the screws? That's the worst rebuild I've ever seen. And here I'm standing here with my wiener in my hand going, man, I ain't got no proof to back up my side of the story. So now we have this here. This is unfolded page by page, and you guys get to see what's going on. And at the end of the day, if somebody has something negative to say, I can go, well, let's go look at the video. Well, this is what it did when it was here. If you can point out to me what I did wrong or what test procedure I didn't follow through on, I'll gladly take care of the problem. This is what it did here. What did you do to it on your side of the street? Another one. I built a 2-pill for a guy. He never wants to tell this part of the story. Built a 2-pill for a guy. He calls me up and goes, man, this 2-pill does amazing. I'm like, okay, what's it doing? He goes, 550 bird. And I went, out of a 2-pill? And he goes, well, yeah. I said, how in the hell did you get that 2-pill to do 550 bird? It had a variable on it. He goes, well, I run it on 24 volts. What? He goes, yeah, I got a battery system in my truck that's set up for 18.5 volts and we charge it to 24 volts. And I'm like, dude, get out of here. He goes, yeah. 3 days later, that dude called me up and said the box burned up and it was a piece of shit and it was my fault. I get it back, Sure enough, the diode on the key-in circuit, 24 volt diode, fried. I put 2 new transistors in it, sent it back to the guy. He blew it up again within 3 or 4 keys and then got on the internet and talked all this smack. The moral of the story is, we have all seen this thing has got some low gains. Once you get below 9, the general rule. Now I know there's going to be some guy out there that says I'm trying to do a transistor grab. Nope. This guy's getting back these transistors. They are not staying here. I do not want them. They do not go into anything else. I don't care anything about these transistors. They're done. They're going to go back to him. If the guy wants to have somebody else put these transistors in another amp, that's up to him. Not my thing. Then the internet's going to be full of, man, I've had transistors a gain of 1 that's been running for years. No, you haven't. Stop it. Stop it. Stop it. Just stop. That's a rough one. I'm going to snatch all these transistors out of here. We're going to check them all here in a minute. And then we're going to clean all the pill pockets out. We're going to strip all this bullshit power wire out of this thing. We're going to rebuild this thing and turn it into a hot rod. We're cruising along here. And I'm down to digging this one out of the back of the amplifier. And I went to lift the first leg out. And I got the smell of Senelic glue. Which is never good. Usually when you can smell Senelic, that means that the lid of the transistor has been off and somebody has tried to glue it back on. Which is a 50-50 gamble, by the way. Sometimes that works. Let's get these out of here. Sometimes you can get the lid to go down and the transistor will work for another little hot minute. Most of the time it doesn't. And then when you go to try and remove the transistor, the lid usually comes off. So this poor amp has seen a lot of country miles, man. That, and it's dirty as hell back here. Come on. There we go. Come on. There it is. Okay. Man, that leg does not want to come up. Solder is super work hardened. Come on. There it goes. Okay. Slipped out clear. There we go. There we go. Now that looks like I'm doing all this prying, and I'm not. All I'm doing is very, very slightly lifting up on the transistor. We got that one out of there. Very, very slightly lifting up on the transistor. You don't ever want to pry. You want to just hook underneath the leg, heat it up, and lift. You don't ever want to torque. That's how you end up ripping the head of the transistor off. Sometimes they're so far gone that it doesn't matter what you do. Some amplifiers, it's actually easier if you just take the whole amp apart and leave the transistors down. Okay, so these are in the order that they came out. These are the 2 that are dead. This is the one that's got a gain of like 5 point whatever. These are 2 in the front. This is the one that we tested that's got a gain of like around 8. So let's start with the one that I just pulled out that smells like Senelic. Survey says 8.6. 8.6. So 8.6, 8.6. This is the one that we've already tested. .1. .1. .7. Yeah, so glad he chose to replace. I'd have been nervous about this one. .2. We're going to come back and double check this one. This is the one that was leaking. Red, green, short. You guys, I got to spend this much time on it because the transistors, we're talking, in some circles, this could be $1,000+ worth of parts. No component detected. Okay, so where's the little Sharpie? .7, 5.2, 5.1, 5.1, short, DED, dead, 8.1, 8.7. All right. Let's quit dicking around with this and let's get on with the rebuild. Okay, so we stripped the whole amp down. It's completely stripped down. We went ahead and washed it. I had to scrub like hell just to get the black out of here. This poor box has been burned up a bunch, and I mean a bunch. If we look down here, we can see where it's been burnt over so bad, the entire trace disappeared right here. Gone. I went ahead and I pulled all the 10 ohms out of it. We're going to put new 10 ohms in it. Well, I did. I went ahead and rebuilt the bias circuit back here in the corner because they had this all remoted. They had wires run everywhere. It was a mess. So the remote wire was broke off, repaired that. But what I couldn't help but notice was this. Back here in the back corner, see this resistor that's right here? This is a 1.8 or a 1.6 ohm resistor. This is what controls the bias. This was just a pubic hair away from catching on fire and dumping 12 volts directly on the input and frying these output transistors. Okay, now that we know that they're, for sure, we know that there's an imbalance and this back section of the amp is having a hard go in life, we're going to pop this capacitor, this capacitor, this capacitor, and this capacitor, and we're going to check them all before we go any further. And the other thing I couldn't help but notice is we're missing some capacitance. You said, but what, BBI? Here, we'll use this as an example. So, on certain Texas stars, we'll have a capacitor here. Well, there needs to be another one over here to make it in balance. What they do in the more modern ones is we have a little stand-up three-legged board that gets soldered in here. The splitter or the combiner gets put onto that, and then there's a capacitor there. Or they won't have a capacitor at all and they wait to have the capacitor over here. Right? In this particular setup, only one side's got a capacitor on it. The same thing over here, which automatically throws the whole thing out of balance. There's no tuning capacitor for this stage. Just like over here. There's no tuning capacitor for this stage, but there's one here. This doesn't make any sense to me. Of course, then again, having an Arco in the thing for our input tune here doesn't make any sense to me either. They never did that, so somebody's added that. This box has obviously been heavily modified. We pulled the PL259 connectors out of it. We've really stretched this down. I don't know what this choke's about. There's no 12 volts on this, so we don't need to have a glitch choke here. This combiner, we're going to replace it. It's got to go. These resistors that are in here, I don't know if you can see this or not, but the resistors that are in here are burnt. Like fried. Look at this. So the imbalance has been going on for a long time. They just keep trying to hide it because they don't know why, and they just kept putting parts in it. These transistors up here were stock. The solder work around the transistors dictates that it was stock. They've never been out. These back ones have been changed many times. We've got the foil starting to come up. I mean, there's a bunch of little shit. It gives away that this thing's been apart a bunch. One more thing that I got to repair before we go any further is I got to repair this trace. This little wire is the easy way. I've been known to do this in the past. Just put a piece of wire there and move on. But then we discovered this stuff called trace tape. So we're going to repair that properly. And let us not forget we got to replace this relay because it's dragging. So about the only thing that we're going to reuse in this thing is the heatsink and the transformers and some of the caps and some of the windings. Now we are going to make this class C. So we're going to come along, we'll take this ferrite bead, we'll take it to ground. This one take it to ground, this one take it to ground, and this one take it to ground. But we can always put it back in class, as they put it, AB1. To me it's class B, by just resoldering this. So I'll make sure to put a new resistor in here, and a new one here, and a new one here, and a new one here. Even though it's not necessary for today's project, I'm thinking about the guy down the road, right? And we're going to come back, we're going to recap it. So we're going to replace old, dried out, and crusted, and broke down and busted. And we're going to put new parts in this thing and make it look all pretty. Then we'll put some transistors down in this thing. And I got to replace this combiner. This thing has been torched so many times. I mean, I've got a few more of these left. And I've got a couple more of these left. So we're going to put a new combiner in this. We're going to put a new combiner here. Brand new PL259s. Repair this trace. And when we come back, we'll have tested these caps. If they're out of spec, I'll cut back and be like, oh, that one's out, that one's out, that one's out, whatever. And then we're going to get on to replacing it. Then we're going to put 8 gain matching HGs in this thing. Once we get that solder work done, then I can go ahead and I can open this hole up. So we're going to put a strain relief here and another one here, and then we're going to put 2 blocks in here so that we can block this off. We'll have 2 strain reliefs, one for positive, one for negative. Negative will come through here, the positive will come through here. Then we'll drill and we'll put our distribution bus someplace over here, and then I can rerun all the positive wire. Then we're going to go ahead and we'll hook up a new fan wire. We're going to make it so that when you turn the amp on, the fans come on. So we're going to take this fuse holder and we're going to move it. We're going to move it over here to the other side of things. We'll probably tie it in right here. And then with some heat shrink, we're going to shrink to the remote lead here. Or not remote lead, but the power on lead. So technically I don't even need to repair this trace. It's just going to be a cosmetic thing. But this little 3 amp fuse is going to carry the current that turns this on and helps us regulate the fans. So if somebody half unplugs the fan in the back, we don't end up with a burnt trace. That's what causes this right here. What most guys would do, I'm not most guys, but what most guys will do is they'll take this fuse holder and they'll put it over here. Honest. And they'll say, nah, good enough. The problem is this trace can't carry enough current to do the amp and the fan reliably. If there ever is a short, 9 times out of 10 it'll pop the fuse and it'll burn the trace. So, but we got to leave the bias switching in line, at least to here. This is what controls our bias switch, and it's, let's see, this wire here that comes off this board. It jumpers to here, and this is what drives the relay. So we're going to put a brand new relay in this spot and get that all cleaned up. We're going to change the capacitance around here. We're just going to overhaul this and modernize it, basically. So let me do some things. Transistors in, strain relieves, clean out some stuff. We'll get the relay changed out, and we'll get some new coax connectors on here, and then I'll check back in with you guys. Of course, I'm going to repair this trace as well. So on we go. Okay, so I just replaced this repaired this trace, right? Now it's all nice and smooth, and you'd never know it had been burnt up, other than it was shiny. So then I moved over here and I started doing the relay replacement. I just took the relay out, and this is the decoupling input capacitor. Look at this. That's soldered down, but it's cold soldered. This is where it was soldered. So that was hooked inside of this cold solder joint, right? Like so. Look at that. Garbage. Garbage, I say. Garbage. Okay. I know it's upside down and backwards for you guys, but this is 1,409.3 picofarads. This is 1,411.3 picofarads. $1,407.1 picofarads. 1,397.9 picofarads. So we are within 3 or 4%. So we're moving right along. Got the new coax connectors installed. Got the new combiner installed, the new primary combiner installed, new relay installed, relocated everything that needs to be relocated. For the little bit extra length of wire, this isn't something they do on normal Texas Stars, but we have to do it to compensate for the length of the relay and the length of the wire. We added 24 picofarads worth of capacitance coupled to ground, which will allow the RF to come in and out very smoothly with little to no resistance. Let's see. Next steps, I got to replace these for the future, whoever they are, and then we're going to relocate fuse, and then we do power wire distribution after we get the transistors in. So it's been about 2.5, 3 hours on this so far, just on this part. Getting this ready to go, getting things cleaned up and soldered down, and like the relay's in there. If you follow what I'm saying, it's not coming out. I even repaired the trace that's underneath the relay for the positive bus, even though we're not going to use it. So, I mean, why not repair it even though you can't see it? Because right is only right one way. All right, I guess transistors in and solder some stuff down. And then we can start working on everything else. Let me talk to you about what I'm doing here. So, the transistor pockets, the screws that held the transistors in are coarse thread, like not machine screws. These are like sheet metal screws, is what was in here. These back four transistors have been changed out so many times that our standard mil-spec concentric self-tapping, self-threading 440 screws can't bite into the transistor bed. And I was like, well, that kind of sucks, because I don't like using sheet metal screws. They don't hold down. They don't have the same amount of capture on the thread pitch area surface. They can't pull down the same. And you got to have a really tight bond between the transistor and the heatsink. You got to have something that's going to grab onto it substantially enough to where it's not going to change the amount of torque pressure, downward torque pull force on the transistor against the heatsink. So short of drilling, taking this whole thing completely apart down to the tray level, pulling the transistors out, and taking the thing down to the tray level, drilling out every single one of the holes, then plug welding up the holes, then coming back and re-punching the location for each one of the transistors, and coming back and re-drilling, then re-polishing the heatsink, which I have done. Another creative workaround is to use an incredibly long 440 concentric screw. Okay, so the heatsink bed is only so thick, and this will only work maybe one or two times, and then you've got to flip the heatsink around and re-drill the heatsink. So like, we could take the heatsink off after we get all the transistors loosely mounted down. We'd solder everything in place, and we take the heatsink off and flip it around 180 degrees and then re-drill and retap. Or we got to go with the plug welding, like what I was talking about. Our other option is to use this long ass screw, and it does two things. Texas Star was really good at how they laid the hardware down inside these things. Very quickly, smart men realized that if you were trying to drill a hole for a 440 screw and you lay it down to where the screw hole comes out at the edge of one of the heatsink fins, it'll take the bit and break it off. So what you got to do is sit back and you got to line the holes up so they land through the middle of the heatsink bed. So what we're capitalizing on is that we have the thickness of the heatsink bed. That's this thick part right here. When we go to thread the screw in for the transistor, it sits about this deep in a hole. So there's still about half the heatsink bed that doesn't there's still like half the heatsink bed that we're not drilling into. Well, they punch the holes all the way through the heatsink. These screws here are the exact same length as the mil-spec screws that we use commonly today. So when these holes get hogged out too much to where this 440 screw won't make contact, we can go and sink a long threaded screw through it, and we'll get it to bite maybe once or twice to where it'll pull the transistor down enough, and it's not going to let the transistor flex with heat. Problem is, my little bag of goodies that I have, I'm short one screw. So it means I'm done for the night. No matter what I do from this point forward, I'm done for the night. What I will do is I'll use one of my other 440 screws. We'll drive this one in, and we'll put another one in. We'll get all the transistors lined up so that we know where they need to sit. We'll solder everything in place, and then tomorrow I can come back and pull this screw out, which will allow the transistor to be in line, and I can zip over to my local screw shop, which here is Tacoma Screw or Fastenal, and I can pick up more of these 440 concentrically head-based screws. I keep saying that because it's really important. If you go to the store and you go buy, let's say go to Ace or Home Depot or the Low Fuck You, The 440 screws aren't mill standard, so when you go to screw them in, the head's not going to be concentric over the shaft, and the head will sit there and wobble. Well, the transistor screws have got to be concentric, or when the head goes down, it'll actually make contact with the body of the transistor and it can break it. Or it'll knock the cap off the transistor, which will ruin it. So you have to spend a little bit more and think about what you're buying for hardware to slap these suckers in there instead of just the cheapest, most convenient thing in the world. It takes a little bit of work. You got to sit down and think about it. Our next option, and final and last most big pain in the ass option, is when the screws come through, the way they've set these things up, they actually ride the heatsink fin. So look, if we look down in here, you'll see the screws are pressed up against one of the heatsink fins. So any little bit of pressure you can put on that screw to help it bite into something to pull down is a win. Other option, the nuclear option. The option no one ever wants to do because it's dumb and it looks shitty, but it works way better than anything else, is we drill each one of these heatsink fins out. So we come through and we drill out a hunk of each one of the heatsink fins, and then with some hemostats we reach down there with a small nut and put it on the shaft of each one of these screws, and then we get a really good pinch action. But that's the nuclear option. So for tonight, for all intents and purposes, this is definitely something so you can hear it biting through the bed that's never had anything put through it before. We can use our little power driver to run it all the way down, but you don't want to let the power driver bottom out because then it might strip it out. So we just run it down far enough to where we can come back and have 2 or 3 turns on it with a regular screwdriver. And when I mean these screw holes are stripped out, these 4 here, I couldn't get anything to bite. This one here is completely stripped out. These 2 are completely stripped out. These 2 are mostly stripped out. These 2 are completely stripped out. As in, like, I can even take this with the aggressive sheet metal thread on it, take the screw, and just with the slightest amount of pressure it goes flink all the way to the bottom. This heat sink's on its last ride without having some serious work done to it. Any real builder out there or any real repair shop will tell you, oh yeah, once that screw hole is stripped out, you're done. See, this one's got a little bit of bite to it. But if I go to torque it down too hard, it will strip it out. There's enough, I'm able to achieve enough torque now with these longer screws that we don't have to drill out the heat sink. We don't have to plug weld it from the bottom back up to the top. I don't have to remachine the surface to make it linearly flat. Nor do I have to deal with sticking this in a jig. Because don't think for 1 second, I don't have a Texas Star jig that's made out of hardened stainless steel that I can just clamp to the top of this heat sink and go dunk 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 with a punch and flip the heat sink around and have all these holes line up, because I do. I've done so many of these at this point. It's just a pattern jig for the punch. Then you pull the jig out and chase it with the drill press and a thing called a torque-o-matic. Wow, these all bit up really good. It's probably why these back 2 have friggin' smoked so many times, is because I couldn't get the transistors to pull down tightly to the heat sink. I babble off a lot of stuff on video, but it comes from hard-learned lessons. Most of it. Well, almost all of it. This is a pain in the ass. This is a pain in the ass when they get this roach down. This is by far not the worst one I've ever worked on, but this is by far the most stripped out I've ever had. If there's one of these that I can't get to bite, that's when we got to flip the heat sink around and re-drill, or weld up from the bottom, machine down flat again somehow, usually sanding, and then come back with a fly bit. Like I got to go to a buddy's shop who's got a mill and come back and recut this, and you use the exact same tool that you'd use to cut the heads of a, you know, like the heads in your car. Big fly cutter. Back and forth, until it's all perfectly flat. Because if it's got a little dip in it or a little wibble in it, the transistor will lose contact with the heatsink and it's game over. So, it's a clever workaround. Something you might want to throw in your back pocket as a possible tool in the future. It works about 80% of the time. 80% of the time. Okay, gentlemen, we're going to knock this out as its own independent segment. This is part of a larger video that I'm currently shooting for a repair on this one particular amplifier. It dawned on me that I've done this probably 200-300 times, and I've never actually shown how to do this on film. What we're doing here is we're going to take this scuzzed out Texas Star Sweet 16 faceplate, and we're going to replace it with a very hard to find brand new Texas Star Sweet 16 faceplate. I thought it would be very handy in the sense of teaching and education that I might actually shoot this video so others may be able to follow in my footsteps and be able to help maintain these things into the future if I'm gone. Never know, die tomorrow, never know. Or it could help somebody else out that's a technician. So our first step that we do is we take a picture of the interconnection of the wires on the switches. I don't need to do that anymore, I've done a bunch of these, right? Please also keep in mind that your interconnection diagram is also available on cbtricks.org. And if you can't find cbtricks.org because it's currently down, remember you always have the Wayback Machine at your disposal, which has a full copy of all the Texas Star manuals, interconnection diagrams, and parts inventory. It's all there for you. So, first thing you do is you take a picture, and then you're going to go and disconnect everything from the back of the faceplate. That's very simply done. Let's go in here and let's take a quick look. You're going to have your positive lead, your output lead, and your LED lead. Then over here you're going to have your yellow and white wire, or orange and white wire, yellow and white wire. Then you're going to have your LED lead, and then this hot lead, which runs the delay. Very simple. It's like 5 wires. Then usually attached to this you'll have a fan. I'm building that into this later on. We're going to change how that's all operated shortly. So that's the reason those wires aren't present in this particular build. Okay. So now what we do with a pair of pliers, and usually your fingers, is we're going to work these switches out of the faceplate. I've never had one of these go smoothly and come out of here like, oh yay, we're ready to come out. No, they never want to do that. I always want to fight you just a little bit. So, small pair of pliers, softly pinch in. We don't want to break these switches. They are available on Amazon, but they're not going to be the black on white. They're going to be black on red or black on blue. Believe it or not, they're still available. But in this stock color configuration, they are pretty hard to find. Go. That's one. That's two. Come on, there we go. Okay. So now it's not uncommon for the switch to do exactly what it just did. Only come out partially and come into the faceplate. That's fine. Don't panic. Now we're going to repeat this process again over here. Please note depending on how the tines are set up, there's 2 on each side, 2 over here, 2 on this side. You'll always have one that bites in more than the other. The one that's bit in is the one that you want to put all the pressure on to get the switch to release. And it'll release through the hole. Just like this. So off comes our faceplate. Shoot, I got the other half of the LED still attached. Hold on. So our LED attaches to the center wire here, where on this side it floats free. And it attaches once again to the center leg, but then the ground leg comes back to the resistor. So now we've exposed the back side of the faceplate. So the next step is to break down the switch. Now we're going to repeat the process. So now we can see we have tines, the little finger stock. You see how this one's bent in more and this one's bent in more? Or this is hanging free and this is hanging free? So the one that's bent in the most, we're going to put pressure on it first, then follow up with the big one. Small one in, big one in, small one in, big one in, small one in, big one in, small one in, and now we're free. Just like that. Remember the orientation of the switch. So now we repeat this process. Back, forth, back, forth, back, forth, back, and now the switch is out. So now we have the faceplate removed. This is an older Texas Star. So we got to clean all the corrosion off, just simply for housekeeping reasons. So we're going to throw a little bit of cleaner on here. I'm going to take my brown Scotch-Brite pad, which is a mild abrasive, and we're going to scrub this. And we want to get this aluminum as clean as we can, get rid of the corrosion. Don't be afraid to push the LEDs back through their hole and continue on with your day. What we want to avoid is scrubbing off any of the anodized coating on the front of the amp, because that's visual, we can see it. If we polish that off, don't worry, if you do, we want to avoid if possible, but if you do, don't freak out. Remember, aluminum can be dyed black with blue gun coat, so bluing material. Now I'm going to take a little bit of 99% rubbing alcohol, and we're going to come back along and we're going to clean this aluminum up. Now the switches technically are strong enough to hold the faceplate on. That's the only thing that held this faceplate on for years and years and years. This thing was probably built in the late 80s, to be honest with you, early 90s. So it's been on there a long, long time. But this will make sense in just a minute. So now what we're doing is we're cleaning off all the soap and residues from your non-ammonia-based window cleaner. And we're taking off all the dust and any stuff that was created by the brown Scotch-Brite pad. Now we're going to leave this alone. We're going to let this dry for a few minutes. We're going to take our switches, which are orientated like so, and set them aside. Now to come to the faceplate. The faceplate for the 1200, the 1600, all of them are basically the same. Here's an extra one that I have for a Texas Star Pinball Wizard, or the pinball, the 3200 but with 2290s in it, so 16 2290s. I have a couple extra of these. I was lucky enough to be able to purchase these before Ranger Corp went through the confusion that they're currently living in. With a clean surface, this is what I like to do next. Turn the faceplate over. We're going to get rid of this bubble wrap. Now this is double-sided Scotch tape. It means it has an adhesive property on the top and on the bottom. We're going to take that Scotch-Brite tape, we're going to clean off a piece of it, and we're going to utilize a piece of this, just like so, center it up on the aluminum. Center it up on the aluminum. Now the idea, keep in mind, is that we have clean metal surface to clean metal surface. Make sense? Good. Made sense to me when I thought about it the first time I did this. Let's grab some scissors. Let's cut this down. Put a piece here in the middle. The only reason we're doing this is to help align the faceplate and not have it flop all over the place. You will discover that some of these switches, the ears in here are very, very brittle because they're very, very old. Depending on the environment the amplifier's been in, the little switch ears could break if you're not very careful. So, faceplate can only go on one way. Power obviously goes to here, the delay switch goes to here, and we have our two LED holes which we want to line up. So let's sit back and look at this for a little distance away. Make sure we're square and even with everything. We lock it in place. Now that Scotch tape allows you to be able to take your hands away from the situation and the faceplate not fall off. It's a very soft adhesive and it doesn't leave a whole lot of residue when the tape breaks off. All you got to do is take, reinsert the switches, push on both sides evenly, and you'll get a firm capture. Firm, solid capture. Now, it could be argued that we want to insert our LEDs at this time, and that you might want to put a little spot of hot glue or something behind the LEDs to help hold them in place. That is an argument that could be had. Me personally, I like to put the faceplate on, put the switches in, and then come back with a pair of needle nose pliers, very small, or a set of hemostats, and renegotiate the LED into its hole. The glue is not necessary. It wasn't there when we took it off. It doesn't need to be back in there when we put it back together. If you have something hitting the front of this amplifier hard enough that it pushes the LED in, most likely it's enough to actually break the front of the LED off. I'd rather have the LED back into the hole a little bit versus having it snapped off. Even pressure, I like to use both sides of my thumbs, or both of my thumbs, even pressure on both sides. Press, lock it firmly in. Faceplate has been changed, it will never come off. I'm so over this amplifier. But I'm going to beat you because I've never had one kick my ass yet. But let me tell you the story. I get this whole thing put back together and I go to run it. And I'm like, can't get the input to come down. And this combiner is getting hotter than hell, this little one here. This end of the amplifier is still perfectly quiet. This end of the amplifier has still got whatever problem it is. Now, first we had this problem present itself. Notice anything wrong here? Yeah. I'm like, why do I have such a serious imbalance? Then I discovered this and I went, oh, that's no good. So I went and I dug around and I found a 1300 picofarad capacitor, and then I piggybacked another 110 picofarad capacitor on the back of it to get the 1410 that it's looking for. Now here's the thing, the 1400 picofarad, this should be 1500 puff, this should be 1500 puff, this should be 1500 puff, and this should be 1500 picofarad. These output capacitors, if this is truly a Sweet 16, should be 1200, 1200, 1200, 1200. But what we actually have is 1400 and 1000, 1400 and 1000, 1400 and 1000. That is the same capacitance that you want to have in there for a Texas Star 1200. I think that there's been a little shediggity going on with this box. The other thing I noticed is they never installed the 330 picofarad capacitors that go from, let's see, base, from the collector tab to ground. There should be a 330 here, one 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 here, and one here. Never been soldered in the amplifier. You don't put the 330 picofarad capacitors in place for the Texas Star 1200. This has the capacitance in it for a Texas Star 1200, but it had Toshibas in it, 2879s. And let us not forget that it had a Texas Star faceplate for a Sweet 16. Don't care about any of that stuff. The amp will work fine either way. We still had our imbalance issue. So first I thought it was coming from this 2-pill section, because this is the most roached out one. So I focused all my attention here for hours and hours and checked every cap, everything's within spec. Well, this was broke, but this is within spec. I mean, I've picked every trace, I've washed it again, I've blown it out, So I grab my oscilloscope and I click onto this edge of this splitter, and I just measure the amount of power on the oscilloscope that this section's putting out. Turn the mic gain off, turn the dead key at just a couple watts, and just measure the amount of amplification factor that we got going on here. We're not going to even talk about all the problems we're having with the input tune at the moment. So look at the quality and the amount of RF that's coming out of just this one section, which is this one here. Then I clip onto this side. Now, when you watch this with the FLIR, you'll see that this side of the resistor, so you have the resistor, you have a resistor in there, and your combiner sits on top. This side of the resistor is getting hotter faster. This side. So that tells me, that kind of points me, it gives me an arrow. It says the imbalance is on this side. So I hook up on the oscilloscope, and the power that it's putting out is significantly more than this, but it's real dirty. This two-pill section is putting out a nice solid, nice linear bass carrier. Beautiful. This side, we have that bass carrier, but then there's a lot of noise added to it, and I'm like, what is that? So first I thought it was a capacitor, and I played up and down on the capacitance, and then I'm like, well, you know, Texas Star, sometimes we run into these things. Texas Star is famous for not paying too close attention to if the fox is in the hen house. Every once in a while we get one of these that come in that have been rebuilt like 19 times because people just keep changing transistors and they never bother to go to try and figure out why the transistor keeps popping. And what we found is every once in a while we'll find that, let's say on this 4-bead piece of ferrite, we'll say this one's type 61, this one's type 61, that one will be type 43, and that one will be type 61. We've even had it where, let's say this is type 43, 43, 61, 43. And it causes all kinds of weird harmonics and an imbalance. So I went, okay, now that I've eliminated the capacitor issue and all of those things, it might be a transformer thing. So the other thing we've had happen is on the bottom side of the transformer, every once in a while the bead will crack. And it causes the transformer not to flux, and that's the actual appropriate term, field flux and couple with the wire properly. Because now it's not completely symmetrical in its diameter, it's broke. It's got an insulated gap in the ferrite material. So I start spinning the beads. And I spin the beads and I spin the beads. And then I see this and went, oh, this one's got a little nick in it. Not enough for me to be concerned with, but I'm at the point now where I'm like, man, I want to change this transformer out for one that I know is a working transformer. So I go and I pull the input transformer out and the output transformer out. This is the stock input transformer. This is the stock output transformer that was in the amp. Going with the idea that maybe one of these is the wrong material make. So I go over to the bone pile, I pull a new, off a used, new old stock used. I buy these amps that are working, I'll pull the transistors out of them, and about every fifth one I'll repill them, or pardon me, I'll repill, let's say 5, I'll take 4 of them, I'll repill them and turn around and sell them after they test and they look good on the spectrum analyzer. About every fifth one I'll take and I'll junk it. I'll pull it apart for the faceplate, the heatsink, the tin body, the switches, the switch face, the knobs, the boards, and for the parts, after I know that it's working, before I strip it apart. It's the only way I can keep doing all these repairs for you guys. So I go over to the bone pile, and I pull us out, new to you, output transformer. Now, can we still get these output transformers? Sure. Call up RF Parts, go get them. Are they made from the exact same material from 35, 40 years ago? No. Remember, early 90s. It's 2026, yo. So 30-ish, we'll be generous, say 35 years ago. I think the material make might have changed. So they're not going to be exactly the same. They won't operate quite the same. So we're stuck having to go back and steal old parts from, okay. I thought, you know what? I don't know if you guys can remember or not. We had this wire here. this wire was going from up here on the on-off switch back here to the fan relay. Remember this? And how it was so scunched and broken and full of corrosion? I got to thinking, man, I want to make sure I get the exact same length of wire. Let's just unwrap the transformers. I'll take this wire, go over to the spool, get off the exact length, and I'll rewrap with the new transformers. This is the input wire. It's got one little nick in it here from a soldering iron from somebody over the decades. Right here. But that's not all the way through the insulation. So now I start with the output transformer. First I pull off the cap and I set it completely aside. Oh, I know where it's at. It's hanging in the capacitance tester still. Remember, this should be 1200 picofarad. It's 952.6. So either magically I've lost 248.5 picofarads, or this is a 1000 picofarad capacitor. I would go with this as a 1000 pico capacitor, and it's at a 5% tolerance. Of course, this son of a bitch been hot over the years. So I noticed that this capacitor here wasn't soldered on in the right place in the transformer. So when I had this off earlier, when I was chasing this imbalance, I measured it and it's at 1000. I also pulled this one off and measured it. It's also at 1000. So we have 1000, 1000, 1000. Odds are pretty good that that's 1000, right? I'm getting frustrated with this box, right? So I start unwinding the output transformer. Now, if we look real close, we'll see that this tube is not soldered in very well. This tube here is not soldered in. This here is broken. We've seen this before. We've seen this before. The front has been soldered together so many times from people not worried about that. But this back here, this bad solder joint here can cause all kinds of problems. It'll cause this transistor to not have enough power delivered to it. It can also cause a resonance issue. Not concerned with that after when I started unwrapping the transformer. You think you've seen it all until you've seen this. So I start from the side that goes to the board. The wire comes off, goes to the board. So transformer sits like this. Wire comes out of the back of the transformer and tags down to the board. So I take and I push this wire through, and when I pull it out the front, I went, well, I'll be damned, look at that. And what we have here, please focus, camera. What we have right here is a complete break in the wire. Look at that. And where is it broken? Right over this edge. Now I don't see any arc burn marks, and I don't see the wires burnt, but we have a failure in the insulation going around this bend around the front of the transformer. So we come around this bend in the transformer, now we're back here on the back side. And I push the wire through. Here's our first break. Here's our second break in the insulation. As it's making its turn around here to go across the back side of the transformer, we have another snap in the Teflon insulation. Look at this. So now we're turning this direction, we're going back towards the front. So we've got a break in the wire here, just as I'm laying it out now. Got a break in the wire there on the transformer, right here. On the front side of the same wrap of wire, now we've got a really significant break. And this one's got signs of being burnt, but it's not burnt against the tube. Remember, this is a grounded piece of wire going through a positively charged piece of material. If it would have shorted to the tube, it arcs and makes a huge black mark. But what we have here is a gray, a gray burn. So let's wrap this back again. This break in the wire and that break in the wire line up perfectly. So I continue unwrapping, and we come forward a little bit further. Now we have a significant snap in the wire. This is on the back side of the transformer right here. So we've started out with our ground wire through, short here, short here, short here, and now we're back around. This significant break lines up perfectly with this break. Well, let's continue on. Now we have a massive break in the wire. I've seen these burn to the tube. I've seen these burn to the tube before. And that's because this is not a folded over edge on the transformer. It's a straight abrupt edge. They didn't put it in a press and crimp it. They just put the plate on the back, soldered it on, put the beads on, put the plate on the front and soldered it on. This can actually, over time, with it vibrating, cut through the insulation if it's not folded over. So I'm like, well, maybe this is my problem. So we continue on. Now we've got a burn through here from the soldering iron. This goes all the way to the wire. Remember, this is Teflon. And we continue on. We got another rub through from the soldering iron. Remember, Teflon. Then we come to this gem. And the amplifier was making power with this wire in the transformer. This and this were on the same turn inside the transformer. And I have a feeling they were doing this kind of maneuver. I think they were making children, little RF pixie children. So we're almost to the end of this wrap, and I'm like, wow, this can't get any worse. So we go from this significant thing to this significant thing. So now a logical thinking individual with our half soldered transformer core, our broken because the wire is older than Christ wraps in the transformer, my brain immediately goes, I wonder what this one looks like on the inside. I wonder what this looks like on the inside. I can't help but wonder what this looks like on the inside and what that looks like on the inside. Because we now know what this transformer looked like on the inside. And after we did an autopsy on the transformer, we can see it's not soldered together too awfully hot. And look at that. Yeah, maybe I'm just punch drunk because I've been staring at this thing for so long, but significant break in the wire. Significant break in the wire. Rub through, soldering iron burn, significant break in the wire. Major break in the wire insulation. Another major break in the wire's insulation. Another major break in the wire's insulation. And another major break in the wire's insulation. So now I've already had to call the customer like 4 times. I'm like, dude, this just keeps getting worse. This amp just keeps getting worse. Because there has been so many problems in the ass end of this amp. Specifically this pallet and this pallet. I look at this wire here, and it has been hit by a soldering iron many a time. That's because the way they put this together to get in here to do the deed of changing the transistor, it's almost a given casualty of war that you're going to have the soldering iron hit the wire. I question this. And what I do have solace in, and I feel comfortable about, is that the front end of this is running perfectly fine, and there's no imbalance. The ass end of this I completely question. So now I have to ask the customer, does he want me to completely rewrap the amplifier? That all looks good, but that's 100% failure. They added this jumper in to short this thing out instead of just bringing the wire around and touching it to the board. But okay. Well, this one isn't too bad. This has only got one catastrophic failure in it. All right. All right. This is the ground side. This is the side that comes from the splitter. That transformer. How is this amp even working? There's another break right there. God damn, another break right there. Look at that. Look at that. Another break right there. And this is the side that was working. There's another break right here. Another break right there. Another break right there. Look at that, son of a bitch. There's one right there. There's two in the front, look at that. Oh my God. How in the fuck was this working? All right. Wow. Well, we're done. Took a little bit of time to get this thing to tune in the way it should. It's pretty flat. It is a little sensitive, so I put an adjustable input tune on this. And you just adjust this capacitor that's right here, and you're just little tiny amount of movement, and it'll adjust down flat for you wherever you want to use it. Oh man, I'm telling you. So I took the windings out and I laid them on the workbench the way they came out. Inputs and the outputs. And I got to tell you, the output that come out of here, in my opinion, was worse than the one that was in here. I had to change transformers, change capacitors. We've now got 1200 picofarad on each one of the output transformers, the way it should be. 1500 on the inputs. Geez, literally every cap and every part I've either pulled out, tested, or had to replace. This box was hammered. That break right there, I don't know why it did not short out. It was the inside wrap, inside turn on the transformer. There's maybe what, 4 pieces, 5 pieces of stock wire left in this thing. 6 pieces of stock wire. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces of stock wire left in this thing. I wasn't going to quit. I can't charge the customer for all of this. We should have given up on this yesterday, right? It's currently in Class C, but it's fully set up for AB if you want to put it back. The thing shits and gets with it, though. I mean, it really does. I just wasn't going to quit. I wanted to see this thing completed, running, making power, and no imbalance. Haven't let one defeat me yet, and that still, to this day, rings true. Okay, let's hook up to the bench supply first. Turn the amp off. Let's go over here. These are all the parts, by the way. All the transistors, the transformers, the faceplate, and every part that came out of this amp. All coming back. Because once you open up the box, look at the bag of shit and go, wow, and then throw it in the trash. Mr. N, like I was telling you, it's up to you what you want to do with the transistors, but they don't do me any good. I know that you told me to just hold on to them, do whatever I need to do with them. They don't do me any good, so I'm going to send them back no matter what. So, we're going to take the derail, bench 955, and we're going to run it into this little straight 8-pill Texas Star. So, we are currently 1000 watt in peak, 1000 watt in peak. Hello, audio. 110 on 1 meter, about 120 on the other. We're going to take this to 2 times multiplier. Here we go. Hello, audio. Hello, audio. Hello, audio. Seeing 1663 on 1 meter and a little bit more on the other. So let's turn and flip our elements around. You can take any reading off this you want. Hello, 1, 2, 1, 2. Now we see the difference, right? Hello, 1, 2. Hello, 1, 2. So now, let's go up here and let's look at our pass-through tune. So that's a 5 watt element in reverse between the striker and the old amplifier here. So here's our pass-through tune with the amplifier off. 1, 1, 1, 1, 1, 1, 1, 1, 1. Here's with the amplifier on. Hello, 1, 1, 1, 1. Hello, 1, 1. So now what I want to show you is with the smallest little adjustment, you can dial your input SWR anywhere you want it to go. Hello, 1-1. Hello, 1-1. Now, let's take a look at both the radio and the meter. Hello, 1-1. Hello, 1-1. Hello, 1-1. And all you got to do is adjust this tuner just a pube up and down, and it'll dial in flat for you wherever you need it to go. So, hello, 1-1. And we're currently running on 15 volts. All right. So, no parts are smoking. That's a good sign. I take that as a good sign. Let's get your power supply and let's put it right up here next to this. Let's put the fan kit on this and make sure the fan's all working and your remote plug's all working. It's all wired Texas Star standard. Fan kit on it, hook it up to your power supply, and let's make it make watts. So they don't use any captive kind of hardware on this. No lock washers, no star washers. They rely on pressure to hold these nuts in place. And I say poo-poo on that bullshit. A man would use some kind of captive hardware. See, that's not even tight. A man would use some kind of captive hardware to make sure that the nuts don't fall off into the part where all the 12 volt voltage is at and can short out and burn up all your shit. So, in an attempt to do due diligence, we're going to come by, we're going to put some Loctite on all the hardware, and we're going to at least do you the favor making sure your shit's tight, so when you get this on your end, you don't have shit flopping around on the inside of your box. And randomly, you plug your amp in, you don't have to worry about the son of a bitch burning to the ground. God, none of this shit was tight. Alright, Loctite added, hardware tightened. The other thing I wanted to point out is I went ahead and I used PIM nuts on your cabinet because, my friend, man, I don't even have the holes right on this side. Got them right on this side? Yeah. You're not going to have a third hole here. And drill the hole in the cabinet in the right spot. Look at that. It's off. If you want to drill it out, that's up to you. But, yeah. You can put the hole in the right spot, man. How cheesy is that? Your sheet metal screws that were holding all this together on the OG setup were all hollered out and they were hanging on by a public. So I went ahead and put the crush nuts in there. So now you can rock big boy 632 screws and you don't have to worry about ever stripping out your hole again because sheet metal screws only go in once or twice and then they ain't tight no mo. All right, we'll be back. So as you're going along in a project, you go and you say to yourself in your mind these little things like, Okay, I got to do this and then I'm done. And then we'll do this and then we should be done. Well, if I fix this, then we'll be done. 13 here has lived up to the challenge of mentally making me go, no, the beatings will continue until it's into submission. One very dorked up power supply and one angry autistically stimulated Sweet 16. Hello, audio. And 1300 watts amongst friends. Hello, audio. Hello, audio. Hello, audio. 1, 2. We're coming through the fans a little bit. Hello, 1, 2, 1, 2. The beatings will continue until submission is achieved. Hello, 1, 2. Hello, 1, 2. Thing works great. Hello, 1, 2, 1, 2. 1, 1, 1, 1. Hello, got down. It's done. I can put this on the wind pile. Yay! It's all working as advertised. I'm never going to issue the RO number 13 ever again as long as I live. Nope, not happening. Not happening. Brother, your power supply is fully repaired. If something happens to it in shipping, I can't help that, but it's leaving here in one piece, and we're going to pack the crap out of it. Your Texas Star, it's a working. Now the RF getting into the cheap fans, there's not a lot I can do about that. It's already got chokes on it and stuff on the inside, so okay, so one last thing, I couldn't just let this go out of here with the fans carrying on the way they were. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Hello, hello, hello. Hello, 1, 2. I went ahead and I took it apart real quick. I added an extra ground wire to the plug, and I added a couple disc capacitors to the plug on the output side. And then I added some capacitors on the switch side of things, and guess what? No noise. So Mr. N, you're all fixed, 100% done. Very, very, very happy with how this turned out. Very, very happy how this turned out. Okay, that's it. I'm done. I think we're kind of a little bit stuck. I know for today, for right now, at this minute, we're done. And it's been a long time since I've had an amplifier earn that sticker as hard as this one's earned it. I spent 3 days on this project in total. Yesterday and today on this, and about a day or so on this. So Mr. N, I'm going to give you a call. Hope you enjoy, have fun, kick ass, go key on some mud ducks. You'll be good to go. Gentlemen, my name is BBI, and without a shadow of a doubt, I'm the biggest mud duck in Idaho. By far, bar none. Hell, I key on duck pluckers so hard, they end up and run out of the state. Move to states that start with A. Oh, I feel sorry for the radio community down there. They're going to get an experience. Anyhow, on that note, gentlemen, I want to say thank you for tuning in, following along. I work on a one-to-one basis. I create the content. If you guys are interested and help support it, come check us out on Patreon. Or just simply subscribe and give us a thumbs up or leave me a comment, because it all helps in the algorithm. The more comments, the more thumbs up, the more YouTube thinks, oh, people actually want to watch this, and it pushes it out there further. So, I gotta go take a nap. Gentlemen, I'll see ya. Click, click.